The weather is one of the most complex of all the Earth's natural systems. An ever-changing balance between nearly infinite variables of temperature, moisture, and geography. Traditionally, understanding the weather was based on the study of temperatures and movements within the atmosphere alone. But scientists are now learning that the atmosphere is only a tiny part of a much bigger equation.
The ocean and the atmosphere are intimately coupled. The atmosphere drives ocean circulation changes, but then in turn those changes are fed back to the atmosphere and that affects the wind field. So it's a sort of truly coupled system, and we can't understand one without looking at the other.
Professor Matthew England from the University of New South Wales Climate Change Research Centre is studying the role that the oceans play on our weather.
The key thing is the oceans absorb a lot of heat, and when they absorb the heat they can move it somewhere else, then release it back to the atmosphere. And when the heat's released back to the atmosphere, it creates air pressure gradients, and as you see on the nightly news, those air pressure gradients fundamentally set where the wind fields are, and that then sort of determines the location of weather systems.
Matthew's work involves generating complex computer models that enable us to compare what occurs naturally and what is occurring as a result of global warming.
We basically run a couple of the world's leading climate systems models, and we run those models with and without carbon dioxide increases. So it's very clear to see between the two simulations what looks different, and we can see very clearly that this jet stream shifts to the south as you increase greenhouse gases.
Matthew's models show a clear relationship between rising levels of atmospheric greenhouse gases and the frequency and severity of extreme weather events in and around Australia.
The good news is we can reverse that trend. The bad news is we have to not only stop reducing the greenhouse gases, but we have to wait for the climate system to return to its sort of pre-industrial state. So in some sense, responding now is important, but the benefits will come through over the next several decades rather than immediately.